one of the most important challenges in European agriculture is the cost and scarcity of labor. This was illustrated vividly during the recent pandemic, when many countries in the EU were not able to welcome field workers from abroad, and some crops could not be harvested and had to be left on the field. Robots have already replaced labor in several sectors of the economy. Robs4Crops aspires to deliver a labor-saving, fully autonomous robotic farming system, together with a supporting ecosystem ready for wide-scale adoption. The Robs4Crops project consists of 3 elements: smart implements, autonomous vehicles, and the farming controller as the orchestrator of the system.
Robs4Crops has established large-scale pilots in 4 countries: the Netherlands, France, Spain, and Greece. Pilots are currently testing components and features, and they are training farmers in using the new robotic farming technologies. In the pilot in France, the aim is to reduce environmental impact of wine growing by replacing chemical weed control in vineyards with mechanical weeding. However, mechanical weeding with a tractor driver is economically not attractive. It takes 5 to 7 passes per year, and the total cost is €800 per hectare. Also, it is difficult to attract and retain experienced tractor drivers who can operate the several different weeding implements that are used. The goal is to replace the tractor and human driver with the robot. In this pilot, the CEOL robot, developed specifically for vineyards, is used in combination with an advanced weeding machine. In the pilot in the Netherlands, the aim is to reduce the environmental impact of arable farming by replacing chemical weed control with unsupervised mechanical weeding. Sugar beets and pumpkins are both crops that grow slowly at first and therefore need several weeding passes to control the weeds during the crop growth season. The robotic robot, which was developed for arable farming operations, is used in this pilot. The pilot in Greece focuses on spraying table grape vineyards. Table grapes need up to 30 applications of preventive and curative crop protection treatments and foliar fertilizer each growing season. Labor costs are high and access to workforce is difficult, especially given the limited time window available for each spraying application. In this pilot, a CEOL robot and an autonomous retrofitted tractor are used to carry a lift-mounted sprayer. The amount of crop protection products used is reduced by adjusting the spray rate to the density of the canopy. An extra challenge in this pilot is the hilly terrain and the dynamic behavior of the robots in this pilot. The pilot in Spain focuses on apple orchards. Catalonia is home to some of the best apples in the world, but they can be difficult to grow due to the high risk of fungal diseases. In Robs4Crops, we are able to reduce the amount of chemicals used by considering the density of the canopy and the disease severity when applying chemicals.
Adoption of robots in agriculture is less than in some other factors of the economy. To tackle these barriers, we will adapt existing tractors and implements to our robotic system. Flexibility is built into this system by means of a digital twin of the farm, which allows the system to interrupt the field operation. For example, when the weather changes, when the quality of weeding is insufficient, or when the robot runs out of spray liquid. We will demonstrate the benefits of our solution in real farms and thereby introduce robotics to the farming community around our pilots.